We're gonna discuss, as I told you, a topic of major importance for all the empirical researchers. Because, okay, let's say that everything runs smoothly and we have our empirical models, we have our empirical results, but then the crucial part is how to report and interpret all this valuable information that we attain from the empirical models and how to honestly communicate our findings in a clear and transparent way. So let me first provide a brief roadmap of today's webinar. We're going to start discussing why it is of major importance to discuss about statistical reporting in empirical research. And we're going to further emphasize on the magnitude of the effects, on the magnitude of the coefficients, on the effect size, and the role of uncertainty in all those outcomes. We're going to show how we can have a publication quality table and figure as well when needed. We're going to discern between cases where we prefer tables over coefficient plots or event study for plots, for example. We're going to apply a case study using event study plots, and then we're going to start discussing about the value of our robustness checks in research, about transparency and reproducibility. And finally, we're going to close the discussion referring to all those AI tools that are available recently, how we can use them wisely, and what we should avoid in order to avoid all those pitfalls in our research. So we need basic knowledge of statistics and econometrics for today's session, and we also need familiarity with Stata. We're going to have some applications in Stata that you can easily reproduce later on your own using the code that I'm providing. So I hope also that the whole session and the available later presentation will help you actually take advantage of some notes, some checklists for your own research later. So let us start sharing a quite simple question that applies to our everyday research. So my question is, what really makes an empirical result convincing for you, considering your everyday research, your everyday activities, and your everyday concerns when producing your outputs? Most of you probably will tell me that one of the important things that you notice initially is whether we have statistical significant results. Typically, as researchers, we're trained to search for all the stars in our output. We also do care about the magnitude of the coefficient, whether our effect is large or not. And we do really, of course, care about how sophisticated our method is, about the novelty and the contribution of our findings. But at the same time, there are many other things that we should not neglect. First of all, robustness of our results. We should make sure that our results are robust upon all those rational specification, additions of control variables, specifications when it comes to other econometric models, etc. We also care about transparency, about how honestly and clearly we interpret our findings. But if you can notice something here is that all those checks that we need the robustness checks, we need our research to be reproducible, to be able to replicate our findings using another dataset or another econometric model. All those acts at the same time do not necessarily need us to provide statistical significant results. What I mean is that we can have results that are not statistically significant, but that are still robust, are still reproducible by other researchers. So this is something that we should keep in mind. But at the end of the day, why it is so important to report our statistical findings in a transparent, in a clear way, why we should care so much about how we we communicate our findings. Considering that, okay, sometimes we can have some novel findings providing contribution to the existing literature. We might have some sophisticated models, econometric, models. So we should keep in mind that once we get the output after running a regression, for example, it doesn't mean that our empirical research stops there. This is only one part of the puzzle. We should keep in mind that after attaining our output, we just have, let's say, a collection of numbers that makes no sense unless we treat them adequately, unless we interpret them adequately. So we need to interpret them. Otherwise, we cannot have scientific knowledge. We just have a random collection of numbers in an output. So we need at least to be able to answer to 4 key questions. First of all, what is estimating after our research activity? And how large, of course, the magnitude is in terms of scale, how uncertain our estimate is, and whether our conclusion is credible or not. In any case, it makes sense to handle the whole process as a sequence of different stages, including the fact that we're starting working with our data, then we proceed estimating our model, then we attain our estimates, and finally we emphasize on the interpretation of our estimates. Again, we can have several outcomes in our research, and my question now is whether comparing result A versus result B, one of those two results is more important than the other. As you can see, we have different p-values, we have different beta hats. We cannot infer, just checking the p-value or the magnitude of the effect, that one of the two results is more important than the other. Okay, it could be a small trap. One researcher might say that, okay, I'm emphasizing on the p-value. I'm emphasizing on the effect of the magnitude. It depends. It depends on the field of research. It depends on your research question, on how uncertain are the findings that you attain, on the scale of the variables. Imagine us discussing about an effect of a policy on, let's say, the life expectancy, the expand of life expectancy, and you attain a magnitude, an effect with a magnitude of 0.01 versus 0.70. So it's different, increasing life expectancy by 0.01 years versus 0.7 or 2 or 3. It depends. So keep in mind that everything can be significant scientifically, not statistically, under specific circumstances. That means that is a totally different thing if we compare statistical significance versus practical significance. When it comes to the statistical significance, we refer to a fundamentally inferential concept. When it comes to the practical significance, keep in mind that practically we need outcomes that make sense in our everyday life, that makes an impact when it comes to a policy, to a practice, to a theory. For example, we do care about a policy that decreases child mortality. We do care about numbers, practical significance. Even when statistically we might attain something that is out of the conventional level of statistical significance. Practically, statistical significance depends on the estimate, it depends on the standard errors, on our sample size. Typically, we tend to summarize statistical significance through p-values or confidence intervals, but it's a different concept for practical significance. And this is something that we should not neglect. We should stop just checking our p-values, whether we attain stars in our output. We should check also the practical significance, the impact in our everyday lives. Some examples here for your reference. Let's say that we have a p-value of 0.04, okay, shall we say that it proves the theory just because the p-value is 0.4? It is not always the case. It's like a binary, strict definition. If we say that we have a p-value of 0.11 in another case, it doesn't mean that we have no relationship. Okay, it might be out of the conventional level, but in any case, we should treat the p-value as one piece of evidence. We need more pieces in this puzzle to have the full interpretation. One example is the confidence interval. The confidence intervals typically give us a research story, and here I'm just providing code in Stata that you can easily replicate with your own variables. In my example, I have 3 random variables, and I want to check the effect on mile age of a car, on vehicle weight, and whether the car is foreign or not, just a dummy variable. I mean, to check the effect of those variables on the price of the car. So we created a coefficient plot here. We have the confidence intervals, and just to remind you, when you see those 3 dots, each dot represents the coefficient estimate for each of the variables. We have our horizontal bars that show the 95% confidence intervals. We have the dashed red line, which is a vertical line, as you can see, that indicates the zero effect. And keep in mind that all those confidence intervals that we have in this graph communicate uncertainly around estimates. So practically, if you see that the bar is narrower, that means that we have a more specific, let's say, estimation compared to a wider bar. In the case of mileage, for example, you can see that the estimate crosses zero. Okay, this is another case. Comparing, for example, vehicle weight with a foreign car variable, you can see that the bar is wider when it comes to the foreign car. Okay, greater uncertainty. So, another thing that we should keep in mind is that we should avoid binary language when we're reporting our results. Okay, for example, let's say that we find that we have no statistically significant effects in one regression that we're running. Avoid stating that we do not have an effect, or the effect is statistically non-significant, or that your hypothesis is not confirmed. Try to handle it in a more mild way. Try to handle it with phrases like, we do not find strong statistical evidence at the conventional levels, for example. Okay, try not to be binary when stating. So I'm just including, an example here, how you can treat your own empirical section when it comes to the interpretation. Typically, we see that many researchers say that, for example, we have a coefficient on treatment which is significant at the 5% level. Try to write it in a more fruitful way. Include the magnitude of the effect, include the standard errors, include the confidence interval. Okay, you can use it later when you're trying to present your own results section. And as a checklist, let's say, if you want to have something like a guidance on what steps you should include in your results section to make sure that your section is full and fair enough, try to include at least those 5 steps. Make sure that you refer to your estimate. What is your main estimate? If there's one main estimate, or two or more. In any case, start with the main estimate and further extend. Don't forget to explain how large your effect is, how large the magnitude is in meaningful always units. I mean, if you're using scale, don't forget to mention it, how precise your estimate is, and how, of course, robust to all those reasonable alternatives, like including more controls, like altering the specification of your model, like using an alternative data set. It depends, of course, on your research. And finally, do not neglect to refer honestly to all the limitations that arise in all the fields of research, in every empirical analysis that we try to provide or even to replicate. There are some limitations. It's not a weakness if you refer honestly all the gaps of the research, all the limitations that exist, all the things that you couldn't apply but you wish to apply. Because actually it serves as a contribution. If you detect some gaps, some limitation, it's of major importance to explain them, to define them, because it helps also other researchers to give it a try to fill those gaps. So start from the finding, proceed with the impact of the magnitude, continue with the certainty and transparent interpretation of the findings, and then proceed with the robustness and the limitations in a clear and a transparent as well way. And here we have an example of how a poor table might look like, a poor reporting example. So as you can see here, we have a table with two columns, okay, name just one, two. And we have some issues here because first of all, we don't have labels explaining our dependent and independent variables. We have too many decimals. We don't have nodes on the model that we used, on any controls that we might use, on any clustering, fixed effects that we use. No explanation of the stars, no inclusion of standard errors. So this is an example of poor reporting. Of course, it says something, but we don't provide all the necessary information to our readers. What we really need is to refer to our dependent variable, to all the units of analysis, to any potential scaling that we have used. For example, have you transformed your value using logarithmic form? We should make it clear. We should also refer to the exact sample size or any restrictions that we might have applied, to the inclusion of country fixed effects, year fixed effects, any clustering, specifically explaining the level of the clustering. Should include standard errors, confidence intervals, explaining whatever it is. Of course, a note section with our model type and the explanation of the stars and the explanation of the model. For example, have we used a pseudo-Poisson maximum likelihood with high dimensional fixed effects? Should this is the case, plus a citation there, a reference to the specific model that we have used, to the specific paper, etc., or the specific database. Explaining, for example, that you have used data from the World Bank, whatever it is. We should be transparent, and this is a better example of reporting statistical results. So here, as you can see, we have the title of the table, the name of our dependent in both cases as price, our independence, our controls, the number of observations, a statement on whether we include controls, yes or no, a robust standard errors, a section referring to the notes, explaining that we have standard errors in the parentheses, explaining what the stars mean, how we attain the data from this specific data set from Stata using the built-in command. In any case, you can use it as a guidance just to make sure that we have those basic concepts including in our reporting. Actually, it serves like a publication style table. If you want to replicate a similar table, I have included the code for you. I have just used the built-in command and the data set, sorry, auto from this data. If you have not already installed stout command, you can do it using the first command. So we just estimate two different models. In the second model, practically we include one control, and then I'm having the command for exporting this publication style regression table. So you can use it for your own research, for your own thesis or paper. You can change the number of the name of the variables, and you can apply and just experiment a little bit. You might have 10 or 20 different models. Again, you can export them, you can compare them. You can have all of them checking what is going on when we include more and more controls, for example, if anything changes in the main outcomes. You can determine also the title. As you can see, for example, in this case, we have determinants of vehicle price. And that's all. So later that you're going to have access to the slides, you can simply copy and paste those commands and in a do file, and you can execute them. Another part now that it's of importance and it is interesting to discuss is whether we should use actually and report tables or figures. So in some cases, we prefer one of them, either tables or figures. In some cases, of course, we provide information on both. But if you want to be more accurate, it depends. For example, there are some cases when we need to provide all the dynamic effects, all the patterns, and show clearly what is going on over time at the long run. We want to also show what is going on the pre-trend part. So in that case, it makes sense to provide a figure rather than a table. We need to show also uncertainty. We need the reader easily to get the main concept of the analysis. In other cases, we might want to compare our models. This could be the example that we saw earlier. We want to check 1, 2, 3 models, including 3 different controls, for example, adding control one by one at a time. And we want to compare the main outcomes, whether they change or not. In that case, it's more reasonable to use a table when it comes to comparison. But in any case, of course, you can use both. It depends on your research question, on your field of research. Plus, you can easily include one of those options, a figure or a table, whatever is more convenient for your own research question, for your own field of research, plus attaining the figure or the table accordingly in your supplementary material, in an appendix, for example. But in any case, your goal should be that the reader will easily get the main concept just checking the table or the figure. That means that we should be very careful when presenting our figures or our tables. When it comes to our figures, we should make sure that first of all, we provide through this figure the main message, just showing one main plot, one main figure, having clear axes. Our x-axis, our z-axis, all should be clear with the units, with their labels. The confidence interval should be also clear. We should have a readable font size. We should be consistent with our scaling. For example, you're using a hyperbolic transformation. We should make it clear in the figure. We should be informative and, of course, include some lines explaining our nodes, like we saw earlier with the figure. So practically keep in mind that every reader should be able to understand the whole concept, just checking the figure or the table, not even reading the whole empirical results section. Okay, the table and the figure should be informative at one glance. Otherwise, we have a serious concern when communicating our results. We should make everything clear. Here we have a second data demonstration that again you can easily copy and paste in your do file and experiment a little bit. I'm gonna show you directly the outcome that you're attaining. So here we create a coefficient plot. We install the command in case that we don't have it installed already. We run a simple regression using again the built-in data set from Stata with those easy and naive dependent and independent variables. And we get our coefficient plot that looks like that. With our command, we export the graph in PNG form, in PDF form, whatever you like. You can simply replace this small part in the command. And you can see here we can just check the uncertainty between the three alternatives. So here we have the label of the figure, the title, our Psi and X axis with clear interpretation, with clear definition of the variables. So it helps the reader understand the main concept. You could also include some notes. So in your research, you can easily, again, replicate the same code with your own variables and attain the coefficient plot. Another example that is really convenient recently, considering the attention of the event studies in related empirical research, is the fact that we should be able to create event study plots in a clear and transparent way, and in a way that the readers can easily detect all the key information that we should provide. For example, the reader should be able to check what is going on with the print trends, with the effects over time, checking whether the effect is long run or short run, checking how precise the dynamics are. And this is an example of event study that helps you a lot recently, because it gives you really valuable avenues for research recently. So I'm gonna use an applied example from my own research. And the reason that I'm using this analysis is that you can easily have access to my supplementary material and experiment a little bit with the code and with the graphs and the commands, so you can replicate it for your own research. So in this specific paper, what we did with my co-author Sotiris Papaioannou is that we tried to observe the effect of terrorist activity on economic activity in the region of Africa. And what we did is that we had actually data at the grid cell level, and we wanted to check whether the effect of terrorism on economic activity exists. And if this effect exists, we wanted to check whether the effect is short run or long run. But as you can easily detect, we cannot easily have enough and sufficient and clear data on economic activity for Africa. So we tried to proxy economic activity using nighttime luminosity. So nighttime luminosity is just a proxy for economic activity. And what we wanted to check is the effect over time. So in that case, an event study works good. Our outcome, over time, the nighttime luminosity, whether it increases or decreases. Okay. And the event was the terrorism shock. Okay. So we wanted to have the analysis on a grid cell level. And if you want to have access to the code and to the replication material, here is the reference for the paper. You can easily have access from Defense and Peace Economics. Everything is uploaded there. So I'm just using the event study plot here to show you how it looks like. So practically what happens, we have two axes. Make sure that you label your axis adequately. We have the event time from 0 to 4 years after the attack, 0, 4 years before the attack. And then we check the effect on nighttime luminosity. As you can check here, in our case, in our example, we refer to inverse hyperbolic sign transformation. It could be also logarithmic form transformation. Whatever it is, don't forget to mention it on your psi-axis. So as you can check, we saw the effect over time. Nighttime luminosity decreases, then we have a small increase, but we never reach the pre-event levels of nighttime luminosity that acts as a proxy for economic activity. This is just an example. You can replicate it using your own data on your own field of interest. Uh, and of course, an extension of all this discussion of our inclusion of publication quality tables and figures is that later we should be able to check the robustness of our findings. It's not just a ticking box exercise, it's of major importance. We should be able to provide robustness checks upon reasonable alternatives, upon reasonable explanations or definitions, new definitions of the theory, or new specifications when it comes to econometrics, or using additional data sets or an extension of a data set, or splitting our sample size. So we should make sure that our findings are robust. Okay, it helps us a lot providing sufficient information, not only to the reviewers, but also to the readers. Some examples of meaningful robustness checks, additional controls, additional country or year fixed effects. We can also split our sample size upon different sample restrictions. We can provide placebo, falsification tests, maybe a jackknife analysis, sensitivity to outliers can be also checked, alternative definitions, several alternatives, but just make sure that you provide some of them depending always on your research question. So as a researcher, of course, you have all the degrees of freedom to apply your own techniques, your own ideas and strategies, but at least we should be consistent and transparent when it comes to the data cleaning. We should explain what we're doing and why we're doing some specific actions and things. We should explain clearly the definition of our variables, why we choose specific models, and of course, we should emphasize on the transparent reporting of our results. In every field of research, either you're working on economics or politics or education or economics of health or religion, in any case, we should be transparent. And of course, transparent means also that our findings should be reproducible. Reproducibility is of major importance. That means that, let's say, I'm having a new paper, a new piece of research, a new thesis, whatever it is. The other researchers, all of you guys, ideally, should be able to replicate my own, research following the instructions that I'm providing, or checking some alternatives or checking some other tests, not only replicating my findings, but also reproducing, given the fact that I'm sharing the data. I'm sharing the code. I'm sharing a do file or a README file that should at least include the software version that I'm using, a nice structure of the folder, some instructions on how to reproduce, and of course, a README file that should explain any specific limitations or restrictions. Or any details on whether I'm having funding for this research, whatever it is. But we should share all the information with our colleagues. This is again a suggestive, a denotative structure of how a README file should look like, including all the different do file on the cleaning of the data, on how we construct variables, on the main analysis, on some robustness checks, on our figures table. It's up to you. It's just denotative. You can keep it for later. You can also replicate and experiment a little bit the whole process. So if this could help as a checklist when you prepare your thesis, a paper of yours, or just a report, keep in mind that we should not neglect ticking the box in some cases, like including the unit of analysis in our sample period. For example, we are providing this analysis and our sample size starts from 1970s until late 2020s, for example. We should be clear. Let's say that for a specific reason, we don't have information for the year 1994. We should explain the reason why we miss this specific piece of information. We should clearly explain any definition of our key variables or any transformations, any scaling, the main specification and any assumptions that we're following, the inclusion of country year fixed effects, any clustering, the level of clustering, of course, and our confidence intervals and all the meaningful sizes when it comes to the magnitude, and of course our robustness checks and limitations, and ideally give it a try to share the data, to share the code, because otherwise the research cannot continue. If we don't share the data, the available information, the code that we might have created, then we cannot also have feedback. We cannot also help other researchers proceed. So it's a fact that lately some things change when it comes to the empirical research. And one of those things that change is that the research is becoming more transparent. Give it a try to be part of this process. Give it a try to share the available information and ideally to justify every step, all your decisions. And if you cannot justify something, it makes sense to explain the limitation. It's not a weakness. It gives a lot to the community. And of course, one of the other things that are changing is all those valuable AI tools that we have available recently and can really support us in terms of brainstorming, in terms of explaining some concepts that we might not be aware of course, in terms of debugging syntactic errors when working on code with Stata or R, for example. Many valuable aspects, many tools that help us a lot, many tools that help us further expand our ideas in research. But in any case, we cannot replace our judgments as researchers using those AI tools. Because there are some, of course, useful tasks like explaining all those errors when drafting some code, like suggesting some notes, some nice labels for our tables or figures, like rephrasing our results more clearly for the reader. but we should check everything twice. We should actually treat this possibility as a research assistant whose work should also be cross-checked. We should not take anything for granted because sometimes those AI tools might drive to some traps, some pitfalls, because they might overstate some claims when it comes to the reporting of our findings. It might ignore some restrictions of the research, some limitations that you know better, but the tool cannot recognize easily. And in many cases, it invents references or even commands when it comes to data or R. You can see many cases. So be very, very careful. Cross check everything. Use it for brainstorming, for debugging syntax errors, but avoid using it for references, for producing code, for stating causal claims. It might be a pitfall. Just including here some examples of some prompts that if we don't provide enough information might give us unexpected outcomes. And here's an example of how we can enhance the suggestion of the AI tool, including our own tone as researchers, our own commands, our own comments, and things that we can easily actually attain when it comes to this data, for example, software, even just checking the help section, plus combining the brainstormings through the AI tools. Okay, so don't allow AI to lead the whole empirical part section, the whole interpretation, and don't allow it to invent citations. Make sure that you verify everything, checking again and again, checking manually, checking your outputs, checking your citations and references. So it can assist us. This is an undeniable fact, but make sure that you can handle the whole process, that you have in mind your research question, you clearly understand what is going on. It's not just a suggestion of the AI tool, it's your own choice based on your knowledge, on econometrics, on statistics, and then, of course, make sure that you're responsible. Write the different sections from introduction to conclusion, and use it for some additional steps that might help you ease and speed up the processes. So closing this webinar, and hopefully, let's say, hopefully this discussion that we're gonna have in the next few minutes, I hope that at least the presentation will be useful for you later, will help you have some checklist for your own reference, some piece of code for your own replication on your own thesis and papers. And of course, remain at your disposal for any questions or suggestions. You can send me at any time an email if you wish with any questions, and you can finally have this empirical, let's say, checklist before submitting your work, checking all the steps, all the necessary steps, at least avoiding to neglect something important. Of course, depending on your field of research, there are many other steps, but those are some baseline steps. And thank you so much for joining the webinar and for your presence here.
Dr. Sava, I will be reading out the questions one by one, and you can answer them as I read them out, okay?
Okay.
So we will be starting with Khalid Mahmood Arif's question, who asks, Many researchers can run statistical analysis correctly, yet they struggle to interpret and report the findings in a way that satisfies general reviewers. From your experience, what are the key principles that distinguish high quality statistical reporting from merely presenting statistical output?
Yeah, as we discussed in the presentation, you can have the checklist and trying to include something. So yes, indeed, we can have a nice statistical model, a nice specification consistent with the empirical concept when it comes to the recent econometric techniques, but one of the major mistakes is that we are trying always to search for stars. We're emphasizing on the p-values, on the statistical significance, and we lack to interpret the practical impact. We forget sometimes to emphasize on the magnitude of the effect on everyday life, on everyday activities. The effect, for example, of a policy on life expectancy, on child mortality, checking just the magnitude in a restrict way through only the numbers of the output. The output that we attain is not a scientific knowledge until we interpret it adequately. Main mistake, searching for stars. Use more alternatives, use confidence intervals, use the whole story, use other related research and explain how it involves.
The next question is from Dr. Ehsan Farooq, who's joining us from Rifa University. He asks, in clinical research, how can we distinguish statistical significance, p-values, from actual clinical relevance and avoid the null acceptance trap or p-hacking?
Yeah, in that case, Dr. Asen, it depends on your research question, as we said earlier. So your research question, the scaling of your specific variables, dependent and independence, gives you the answer. If we have a magnitude of a policy on health outcomes, for example, and this effect is really small in magnitude, it might be meaningful when you use the appropriate scaling. So it depends on the type of your research question and on your specific variables of interest.
The next question is from Muhammad Saeed, who asks, if statistical conclusion depends on assumptions, how can we know whether a reported empirical result represents reality rather than merely the assumptions used to analyze it?
Sorry, I had a small disruption from Professor Muhammad Said.
Yeah,
Let,
the question is, if
yeah.
statistical conclusion depends on assumptions, how can we know whether a reported empirical result represents reality rather than merely the assumptions used to analyze it?
Yeah, robustness checks would be a good starting point. And of course, before that, reading the related literature on econometrics, on the inclusion of control variables. We try at least to proxy the reality, to include as many variables as we need to make sure that our analysis is not biased. Then, with all the robustness checks, with all the cross checks, we can minimize the possibility that this is an artificial effect. And also robustness, not only in terms of including more or less controls or splitting our sample size, but also on the inclusion of alternative data sets, on the inclusion of alternative econometric specifications. So combine theory and experiment a little bit with the data, providing as many robustness checks as you can.
The next question is from Pervez Ali, who's joining us from SMBB Medical University in Larkana. He asks, when interpreting a study with statistically non-significant result, p less than 0.05, how can we effectively communicate the clinical or practical importance of the findings without sounding apologetic?
Well, first of all, whether the findings are statistically significant depends on our own definition, on our notes of the meaning of the stars, the meaning of the p-values, as you refer. So you could explain, like we saw earlier in one of the examples in the presentation, that one effect might not be statistically significant at the conventional level, yet it might have a practical significance, or it might be close to the conventional level. We don't act like apologetic. We provide the real story, and we provide also any possible limitations. So explaining that we are not statistically significant with this finding at the conventional level is a good strategy that you could apply.
The next question is from Professor Dr. Tajnees Pirzada, who asks, we use the descriptive statistical analysis tool in Excel and get detailed statistical analysis. How can we apply this method for the said purpose?
Uh, Sorry, Zara.
It's okay. I'll repeat the
You- Could,
question.
could you
We
please
use
repeat
the
it?
descriptive statistical analysis tool in Excel and get
Uh-huh.
detailed statistical analysis. How can we apply this method for reporting and interpreting statistical results in empirical research?
Well, it's a different thing. If you want to provide evidence, if I understand correctly now, the question is the main part is that we should attain our data. So we should prepare our database, cleaning our data, defining our variables of interest, gathering all the data that we need, and then proceed with the empirical analysis, applying the appropriate econometric technique. So, descriptive analysis versus the empirical analysis, and what our colleague is describing here in this question in Excel is a totally different thing. So, you gather the data. Of course, you should keep in mind a specific research question. And based on those data, you apply the econometric techniques that you wish, you run your regressions, you attain your results. This collection of numbers initially that you then interpret, and everything makes sense and everything applies to your own research question. And then you can have your empirical analysis. And you can either use Stata or R or any statistical software that you wish. Uh, Sorry, Zara, I cannot hear you.
The next
Zara?
question is from
Yeah.
Dr. Albina Wasim, who is joining us from Formal Christian College. And she asks, how can the data collected through codes in apps like NVivo be more empirical so that it's more ethical as well as objective?
Ethical, well, it depends again, depends on your field of research. Uh, when we collect data from some specific databases, those data have passed, let's say, an initial check, and this database has been created from other colleagues, from other researchers, and we know that they attain very specific information under strict criteria. When we create our own data, when we create and trying to attain our own data through questionnaires, for example, through some activities like the questionnaires, in most of the cases, we should make sure that we have an adequate sample size. Let's say that you're creating a questionnaire. Okay, avoid sharing the questionnaire only between your peers or your colleagues or your friends or your family. Try to include as many different population groups as you can. You need a large sample size accompanying all those different characteristics of the population, age characteristics, ethnic characteristics, religious characteristics, different genders, different marital status. Okay, because it might be the case that we attain some biased responses from the people that reply to our questionnaires, and this makes our research to be biased as well. When we attain data from databases like the World Bank, like the START Consortium and the Global Terrorism Database, for example, in my research, we know that there is a specific check before gathering those data and some specific criteria.
I think that was the last question, Zarek.
Yes, ma'am. Since we're short on time, we can't really take any more questions.
Okay. I think the question, thank you, Evie, for your talk. I listened to part of it. And I saw that most people are sort of confused between the statistical inferences of p square, p values, and so on, and they sort of discount the other factors and variables that may impact on the research conclusions. And I think there is that bias and how to towards the statistical data. But there is a need, like you said, for bringing in robustness with relevance, to the context as well. You're talking about a wider view that makes sense in once you come to your conclusions, and you're also talking about that your. I think what is key is that one should acknowledge their limitations if they come across any, and those limitations in all research sessions that we have done. I think citation of limitations is the starting point where you put your parameters to your research and make it very clear what you can do and what you cannot do and what you will have to discount or the reader will have to discount while going through that research. We talked about also, I think, a bit about AI and the uh, integrity that comes with it and how to deal with that. So we are very, very thankful to you, Evie. And uh, though you had an accent and we have an accent for you, on both sides we are dealing with accent. But I think you were very, very clear. You're very audible to our style of speaking. And I thank you for your effort and I thank you for your commitment to, make this happen. So you've been very, very on dot and responsive to our questions and our emails. We bothered you a lot, I think. So it's a
Thank
joy to meet you and thank you so much.
Thank you so much, Roxana, for everything. Thank
Yeah,
you for the great organization and all the coordination
I
of
know.
all series of webinar. And many
Yeah,
thanks to all the participants for joining the session.
yeah, yeah. That I have to thank Zarek and Fatima for all the coordination and bringing this together. So thank you everyone for being here, and we hope that you are able to take back some learnings from these sessions. And we'll be bothering you every year, every
Yeah,
if
great. Would be very happy.
yeah. Thank you so much. Thank you. Bye bye.
Thank you. Thank you. Have a
Bye.
nice day.
You
Enjoy
too. Thank you.
summer.
Yeah,
All
I
the
know a
best.
long way to go yet. Thank you.
Yeah, enjoy, enjoy. So,
Yeah.
thanks a lot.
Bye. Bye.